Hello guys, welcome. In this video I'm going to be building the WellGood loop. This is the version 4, the latest version. This is an absolutely fantastic little active loop, so that means it is powered. It was designed by M1GEO George and G8OCV Chris. Now I'll put a link down in the description to George's website, and I think you can actually email Chris if you would like one of these. The build that I'm going to be doing is very heavily influenced by Mersey Radar, and I'll put a link to this build as well. It's just, it's really good, and why do something else if there's already a good idea. So I'm going to use pretty much what I've actually just got to hand here. But you'll see the similarities if you look at the Mersey Radars build on this. So what you actually get is a bias T, so this would go in your shack. This actually needs a 12 volt supply fed to it, which then goes out down the coax to the loop amplifier, which you see here. Now this has actually been designed for a little electrical junction box, but I'm actually just using a square box that I have to hand. These are waterproof boxes, but we will put some additional sealing on this. So this was me actually looking at this for the first time. So I need to actually measure the BNC first, because I don't know the diameter of the thread on the BNC. So once we do that, we can look at marking up the box and then drilling the hole for it. 11.9, so yeah, 12 mil. So using my trusty steel rule and mechanical pencil, I just want to roughly mark it. So I want to mark in the middle of this. So put a little line down there. Now I don't want the PCB actually sitting on the bottom of the box. I'm going to make some makeshift standoffs a little bit later on, but I just want to get my positions right first. So what I've done is I've come up half the diameter of the BNC from that point, and you can see. So it's going to stand off a couple of millimeters from the bottom, and then I need to transfer those sizes to the outside of the box. Now, if you mark it with a pencil, these marks will wipe off completely. So this is a step drill. Now this it's just a cheap one. It's got 1 millimeter increments, which I find really handy. Normally they're 2 millimeter increments. And normally I would do this over a bin, just for the swarf that comes off it. But for the benefit of the video, I want to show you this. So this goes to 13 mil. So just one step down. And even then that's just slightly tight. So we've got this little rotary deburr tool. These are great, really cheap from Amazon, and you get them with a little pack of blades, interchangeable blades, and I use them for deburring the edges, and also just you can open up the hole if you want in plastic a little bit more. Yeah, there we go. So that's just starting to fit in now. So trying it from the inside, I'm just trying to gauge how much space there is underneath it, because you can see there is a gap, but that's good. Yeah. So we have two SO239s that we need to fit. Now I'm going to be using a Mersey Ultraflex 7 loop, but I'm only going to be using the braid, so we won't connect the center conductor. Again, I just looked at this by eye. Measured it. Yeah, I need to make a 16 mil hole saw hole in it. So both sides marked. But before I'm going to drill it, I'm going to obviously remove the amplifier board, because I don't want to risk damaging it. So using a bigger step drill, this is 2 millimeter increments. This is just one from Screwfix. Again, take your time with this. If you press too hard and your drill is blunt, you'll end up going too deep, making the hole too big. Nope, we need to go one more. And while we're there, we might as well just do the other side. These boxes are really nice to cut. I'll put a link to these down in the description, and they're not expensive. They're a couple of £1 each. but they've got a nice lid with a seal on it, and it's just a half turn to remove the lid, and that's what I really like about them. And they're nice and thick as well, as you can see. Let's get tidied up a bit. Okay, so now we want to fit our ISO 239s in, so there's two M3 holes. So, oh, my drill's a little bit squint here, as you can see, but we've still got the pilot done. So let's just finish off that hole. I've actually straightened up the drill. And then once you get one hole drilled, you can put the ISO 239 in, put in the M3 bolt, hold it in place, and then drill the other one. Nice and simple. And then you know it's going to fit. Simple as that. On with the other side. Done. Now we're going to fit our ISO 239s. Now I'm using longer, these are little dome head cap screws that I just happen to have. I predominantly use M6s, sometimes M4s, so 3s are pretty rarely used. But I do have a little kit here which you can see. These are all stainless steel, A2. And these are M3 threads, remember, so they don't need to be really that tight. As long as you've got them nipped up, I've got a little flat washer and a spring washer, and that's good enough. So I'm just going to hold the nut at the back side. I do have a socket for this, which I get out later on from the build. But yeah, it doesn't need to be tight. As long as it's nipped, it's not going to go anywhere. Same with the other side. Now these are M0 MET connectors. I'll put a link to these to Matt's eBay shop. These are first class PTFE gold plated contacts. So now we've got our amplifier board, and I need to get the standoffs made for it. So I'm going to use M3 bolts. So I've got an M3 bolt, 2 nuts on it, and you can see that now stands off. So I'm just using it to suit the BNC hole that I've done. Yeah, that's okay. Probably lucky more than anything. So now I've got the 2 on it, just to try it again. That's sitting nice and level. Good. So now we're just going to put nut and washers on the other side, because we're not actually going to solder this, as Mersey Radar did, or didn't, because I can always put it in a different enclosure. So just tighten up our BNC. This looks like I'm tightening it really tight, but I'm not putting a lot of pressure. Remember, it's only a plastic thread, so it will strip easily. Now we actually want to connect the amplifier board to the shield of the SO239. So again, these are new to me. These are 3mm ring connectors. So I just got these off Amazon, and I just bought the pack of 100 because I thought I'm going to use these. But quite often I like to remove the outer. So this wire is silicon coated wire. It's really nice, really supple, really good to work with. Tin coated copper wire. Take my crimps, let's just crimp that in place. I'm going to solder these as well, just to give it that little bit better electrical connection. So we take one length, and then we just want to see, right, how long does it need to be, and then it'll be exactly the same for the other side. So yeah, we've got our 2 wires made up, crimped, so now we just want to solder these. And I quite often just use the flame of my Super Pro 125. It makes things a lot quicker when it comes to soldering, especially connectors, ring connectors, etc. But this is lead cord, fluxed core lead and tin solder. So I like to wipe the flux off with a bit panel wipe degreaser. So these are now ready to be fitted. So they just need a washer, spring washer, and a nut. Now my hands are a bit like sausage fingers for these, a bit fiddly. And I'm just using a socket this time from my quarter inch socket set, and I'm just tightening these up by hand. As long as the spring washer takes up the tension, that's good enough for me. As long as we've got that electrical connection. So this is part 1 down. So I don't know why, but I got out the multimeter just to see if there was continuity, which there is. Putting on our lid. I still need to get a way to connect the lid to a mast, so I'm probably going to drill the lid and put a V-bolt or a Stouff clamp or RSB clamp. But you see, I mean, these just need 180 degrees and they lock in. Really good enclosures. And not expensive. So that's the first part done. Nice and simple. There's not a lot to this. It's a good beginner project. So as I said, for the loop we're using Mersey and Poloni Ultraflex 7, because I was going to use RG213, which is a bit stiffer, but the shield has 100% coverage. It has the braid, but then it also has a foil braid, copper foil braid. And I actually had a couple of connectors that I'd previously used, compression connectors. And if you go careful with these, don't over tighten them, you can reuse these, as I have done here. Now I'm going to connect the centre core, but you don't need to for this. But what I think is, if I'm going to upgrade the loop, which I might put a solid copper tube, then I've always got another patch cable here to use for other radio uses. Cables are, at the end of the day, cables are consumable, so you need to think about it like that. I only ever fit compression fittings now. Sometimes I use crimp connectors, but I pretty much exclusively use M0 MET Matt, again from his eBay shop, which I've said I'll link down in the description. These connectors are just that really good priced, and his service is brilliant. Everything's sent first class. You order normally, if I order it at 2 or 3 o'clock in the afternoon, it's posted that day, and the service is that good. You can see that foil covering that I was talking about. It just needs a little nick and then you can peel it off. Now, habit, when I fit the little top hat here, sometimes I heat the sheath of the coax, and it just makes it supple, a little bit more supple, and sometimes that can help with the top hat. This really doesn't need it, this coax, but that was just habit. Yeah, let's trim our braid down now, so it actually fits inside the connector and we don't get a short. Although in this case I said it wouldn't matter. Now the dielectric on this coax is like a foam. It's really easy to cut and peel off, as you could see. Let's try on our tip connector. Yeah, we need to trim that a little bit. It's a little bit sticking too far out. Take our side cutters. And that's what I was actually doing off camera there. So fit this on. Now we're going to solder it, and I'm going to use the flame again. Using this little vise. I need to get one of these little fourth hands or whatever you call them. Yeah, and again, wipe the flux off with panel wipe. Put it on the connector and then just screw it together. But remember guys, don't over tighten this. Because that big rubber washer will crush and form a seal. So I think the spanner we need here, we need a 15 and a 14. Yep, that's it. Same with the other side. Now this is a 5 meter length of coax. Is going to give me what, 1 meter and a bit diameter of a loop. As I say, I can actually come down a little bit, but I'm probably going to go to a solid copper tube eventually. Now this is going to get me going in the meantime. The bigger the diameter, generally the better it is. And for a little bit extra connection, a bit of sealing, I'm using my heat gun with a bit of glue lined heat shrink. And this is a 2 kilowatt heat gun, and this is taking a little while. This is really thick heat shrink. It's good stuff. You can see it's slowly starting to go though. But I will put some amalgamating tape around the front of the connector once it's actually on the box, once we get it installed outside. And the installation and the use will be a following video. So if you're not already subscribed, please do so, and you can actually follow along, because I'm going to be doing some RX antenna experiments with this and a loop on the ground. So that's our coax loop built. There's our loop amplifier in its enclosure. Now we need to get the other bit built. So this is the bias T, so this is what's going to be staying in the shack. Now there's a couple of different ways to power this. So you can use a little PCB 2.1 by 5.5 socket, which I bought from Amazon, and that's what I'm going to use here. But Mersey Radar, there's another connection you can actually solder into if you want to put the plug on the outside of the box. Now this is a Hammond enclosure. I'll put a link to this. Not expensive, but it's a little bit small. Ideally it would have been a little bit bigger. The other enclosures I have are much bigger, so I need to try and get this to fit somehow. And this is me just coming to the realization, yeah, I'm going to have trouble here. So as you'll see a little bit further on, I would like this to be a little bit neater, but never mind. So there's a couple of little standoffs inside this box for mounting a PCB. So I just want to drill that off, just to give myself a little bit of extra room for mounting. Yeah, so this was the socket that I wanted to use. I wanted to just solder this into the board, but you could see that, yeah, there's just simply not enough space to install that, and also put in the PCB. So we're not going to do that. We're going to solder on this little PCB mount. So thank goodness that we've got this facility on it. But I would have just used a bigger enclosure if that wasn't on it. Now, I mentioned earlier there, I don't have one of these little third hands or fourth hands, whatever they're called. I really need to get one of those. Help me with soldering. And I really need to invest in a good temperature controlled soldering iron. So if you can recommend something around about the £100 mark, that would be great. But I don't do a lot of soldering on PCBs, so normally this does me, and it's nice and hot. So distance between the BNCs is 35. These ones were a little bit squint, so it was about 34. But down at the base it was still 35, so we're going to drill our holes just slightly bigger. Yeah, but I want to just offset it ever so slightly. So again, take our mechanical pencil and just mark the centre of the BNC. And then take our steel rule and mark 35 along. And then once we do that, we need to work out our height for where we're actually going to drill the holes. And I'm looking at this thinking, it's actually going to be easier putting this upside down. So again, using our hole saw, our hole drill. Yeah, and I can't quite drill it big enough because it's a little bit too long. It's going to hit the other side, but I thought I'll use it on the other side, put the pilot in it, and I'm going to open it up just by hand with the bigger step drill that I have to get to the 12mm, or just over 12. Yeah, so there we go. I was going to put this in the drill, and I put it in by hand, and it actually was fine, soft enough. Yeah, so once we open this up, we're going to need our rotary deburr tool again. Yeah, always check. Remember, it's impossible to put material on, but it's always easy to take some off. There we go, that's nice and snug. Trying it from the inside. Perfect. Now, I did know this. I knew that this was going to be an issue. These lids have got little lips on them, so it's not going to go. So you can see how neat fitting it is with those BNCs. So what I do is that I'm just going to use this craft knife and I'm just going to trim off the lip on one side of the enclosure. Remember, this is going to be inside, so it doesn't need to be sealed or anything. I need to look and see what the next size up hammered enclosure is. That would be better. Yeah, that's going to work. There's two screws in that, one in the opposing corners, diagonally opposing. So now we need to drill a hole for our power supply going in. So that's easy to mark. But getting the height right is not quite as easy, so what I've done is I'm just measuring the height from the bottom of the board to the middle. I think that was 7.5, 8 mil. I think I just measured it at, drilled it at 8. I'm going to make it probably 9 or 9 and a bit anyway, because you've got the outside of the connector to take into account. There we go, there's the connector there. This was actually quite snug. I think it was just because of its first time use, and then it actually got easier after that. So let's drill our hole. Normally I just run this at the slow speed, and if your hole drills are actually getting blunt, just buy a new one. They're not expensive. So let's try our plug. Yeah, it's not quite enough. Let's go another 1 millimeter. Yeah, it's starting to go, but not quite tight enough. So not quite loose enough, sorry. Right, let's try it again. Yeah. Yeah, I think that's going to be okay. Now, I'm sure these must have been designed for some sort of enclosure that's a little bit neater, but I'm not quite sure what that is. So there's a little LED on these boards, and I'm going to actually drill a hole, and because I just want to actually be able to see that. You can fit an external LED like Mersey Radar did, which is a really good idea, but I didn't have the room in this box, so I didn't bother. Now you need to mark which connection is which, so we need to mark one for the loop and one for the radio or the receiver, which is what I'm doing with this scribe. L and R. This is obviously a flange box, so my idea was I could fit this to something. Again, tighten up the BNCs, but do not put any sort of tension on them, just nip them. Now, before we actually go any further, I just want to check, see if this BIAS-T is powering up. So I have a power lead here already, and I just want to make sure that it's centre positive, which it is. And I've got a small lithium iron phosphate battery here. So let's plug that in. And then when we plug this in, we should see an LED somewhere lighting up. Hopefully. Hallelujah. There we go. And that's just so that we know that we've got power to the board. So let's put the lid on. We don't need we don't need to be in there again. So that's our BIAS-T made. I don't think it's the neatest, but I think it'll work. It'll be fine. It's going to be out of sight anyway. So that's our loop amplifier, the BIAS-T. Yep, and there's our coax loop. So that's what we've done so far. So guys, as I said, if you've not subscribed, please do so, follow along. And then the next video in this series on the WellGood, I'm going to be putting it up and trying it out. I said earlier that I've also got a loop on ground, because I'm using the TS590 here, and we can do some comparisons, and because I do have quite a high noise floor level. Okay guys, 73, all the best. Hopefully we'll see you in the next one. Bye for now.